Hello everyone, it's Mahathi with the Global Cli-MATES Introductory Earth Science course, and today we'll be working on the second video in the course, which is studying the differences between physical geology and historical geology. Last time we looked at what earth science is and realized that earth science is actually composed of many sub-sciences, many subfields within all of earth science, and one of those subfields we talked about was geology. So as a quick recap, geology is the study of Earth's rocks, rock formation processes, and also various structures. And so when we talk about structures, we look at the structure of the Earth itself, but also structures that are visible on the surface of the Earth. So now that we kind of have geology as a whole field down, geology can be split into two smaller subdivisions. And these two categories are physical geology and historical geology. So let's first take a look at physical geology. So physical geology takes a look at formation, rock characteristics, and other geological characteristics and other geological features now. So this is kind of the key word with physical geology. We're studying what the Earth looks like, the composition of Earth structures as they exist in the present. So in addition to looking at these various structures, we can also think about the processes that are studied in physical geology. So in addition to thinking about the composition of a certain rock, physical geology also looks at the current processes that shape these structures. So what caused the rock to be that way, and why do we see this tall rock standing in the middle of this desert? So when we think about these processes, we can actually find that there are two primary processes that operate in the present. And so these two categories are internal processes and external processes. And the names of these processes are very self-explanatory, but to give a quick example of internal processes affect Earth structures and rock formations from the inside of the Earth. So the source of these processes are found in the inside of the Earth. And so one example we can go over are volcanic eruptions. So if we have a volcanic eruption, they affect rock structures and formations on the surface of the Earth, because when these volcanoes erupt, they create new rock and can change the surrounding landscape. But how do volcanic eruptions happen in the first place? Well, molten magma from the inside of the Earth is brought up to the surface, where it then erupts. So we can see that with volcanoes, a process that's happening underground is what leads to this volcanic eruption that changes Earth's structure on the surface. Now, another type of process is an external process, as we mentioned earlier. External processes occur on Earth's surface, as can be assumed by the name. And when we think about, processes that are happening on Earth's surface, one example we could look at is an example with a river. So if you've ever been near a river, you might have noticed that the rocks surrounding the river are all very smooth and rounded. And part of the reason for this is as the river water washes over this rock, over time, it can polish these rocks and smooth out imperfections in these rocks through a process known as weathering, which is just breaking down rock. And so this is an example of a process occurring on the surface of the Earth that changes, rock formations, right? So in this case, these rivers on the surface of the Earth are going over rocks and making them smoother. So that's basically it for physical geology, right? We saw how physical geology looks at current processes, current formations, and current structures, and we also took a look at the different types of processes. So the next category of geology we can take a look at is historical geology. So historical geology studies processes and formations from the past. So one important thing to note when looking at historical geology is how old is the Earth? The Earth is actually 4.6 billion years old. And so because it's so old, there has been so much time for things to happen in the past. And within those time spans, maybe things were occurring differently than how they occur today. Now, to give you a better sense for the scale of the Earth's age, I want to first think about an example. Maybe in a social studies class, you learned about an ancient civilization that lived several thousand years ago. And we call that several thousand years ago to be ancient. But in reality, when looking at the whole context of Earth's history, this is a really small thing. So one thing I would like you to think about is, well, what if we put all 4.6 billion years of Earth's history into a calendar? All right, so here's our calendar. We're putting it into one calendar year. So in our one calendar year, we have January, February, March, April, May, and June. Then July, August, September, October, November, and December. So we thought we gave that example of a human civilization that occurred thousands of years ago being ancient. Well, if Earth's history was one entire year, humans would actually appear in December, and not just in December, but on December 31st at 11:49 p.m. So humans actually live on Earth for 11 minutes out of an entire year. And so when thinking about historical geology, new concepts have been developed to better display this, most notably the geologic timescale. So the geologic timescale, which we'll cover more in depth in a future video, essentially maps out and divides Earth's history into manageable chunks so that historical geologists can better analyze and study processes at various points in Earth's history. So today we covered geology more in depth by taking a look at the differences between physical and historical geology. And the primary difference we saw is that the time frame in which Earth is studied affects whether we're looking at physical geology or historical geology. Another thing we talked about were processes and the different types of processes. We can have internal processes that are fueled by energy and systems that are operating beneath Earth's surface, but we also have external processes that are happening on Earth's surface that are visible to us. I hope this video was helpful, and if you enjoyed it, don't forget to subscribe, like, and comment down below if you have any questions or suggestions for future content. Thank you all for watching. It's been a great time,